So we're dealing with some more fractions here. All right, go ahead and read question number 19 for me, please, Jackson.
Which of the following inequalities is true?
Okay, you know what an inequality is?
Um, I think so.
Yeah. I mean, it's kind of like, do you know how to read inequalities?
Yes.
Okay, okay. Like, let's just talk about inequality for just a minute. Let's take answer choice A. We got to find which inequality is true. And let's take answer choice A. How would you read answer choice A? This guy right here.
3/4 is greater than 5/7.
It's actually the opposite. We'd read that as 3/4 is less than 5/7. And this takes me back to like middle school, maybe like elementary math. This is how I learned it, and it's always stuck with me. Okay, if I've got an inequality, and I don't know whether this one's true or not, I'm just going to write it out. Okay, but I've got an inequality like 3/4 is less than 5/7. Here's how I learned it as a student. It's just always stuck with me. I turn the inequality sign into a Pac-Man. Right? You played Pac-Man before?
Yeah.
Maybe not. I love me some Pac-Man. Pac-Man wants to eat the bigger number. Right? He doesn't want smaller. He wants a bigger number. So we could read this as 5/7 is greater than 3/4, or 3/4 is less than 5/7. But the mouth is always the mouth of the Pac-Man is always going to be directed toward the bigger number. Does that make sense?
Yeah.
Just an easy little trick to remember. That if you literally need to redraw these with a Pac-Man, do it. I'm 100% cool with that, dude. 100% cool with it. Does that make sense?
Yeah.
Okay. All right. So 3/4 is greater than, or sorry, 5/7 is greater than 3/4. 3/4 is less than 5/7. Now, do you know whether 3/4 is less than 5/7?
I would say it's greater than. It looks like it is.
Yeah, it's close, man. That's close. That's tough to, like, potentially. And maybe this is something worth doing. Is let's make this concrete. Like I would love to take two rectangles. In fact, I'm going to do that. I'm going to make two rectangles here. Something like the same size. Okay. Use that little rectangle function. And let's divide up that first rectangle into 4 parts. Okay. And I'll take care of that on the whiteboard. I'm done into 4 parts. So I'm going to split it in half first. Ooh, that was not pretty. Split it in half. That's pretty good. Think about that first rectangle divided into 4 parts, right? Does that make sense? And then 3 of those parts are going to be shaded in, right? 3 of those parts are going to be shaded in, so it'll be like something like that. Okay. Those parts are shaded in. Okay. And then 5/7. Ooh, this is going to be tricky. I'm going to try to divide this into 7 parts. This is an undertaking. Okay, something like 1, 2, 3, 4. That's more like 6. Hold on. 1, 2, 3, 4, 5, 6, 7. Okay, something like that. Okay. And then 5/7 is going to be something like this. That's close, right?
Right.
I can't eliminate that, just logically. I can't eliminate or confirm it. Okay? But that's the approach, right? Is to make it concrete. Again, I'm trying to use basic logic and basic estimation here. Does that make sense? Those are close. Let's try answer choice B. Go ahead and read. So we'll leave answer choice A. Read answer choice B for me, please.
2/3 is greater than 5/6.
Okay, is 2/3 greater than 5/6?
I think they might be equal or something. They're like, I'm not sure.
Well, let's do the same thing with the rectangles. All right. 2 rectangles, something like equal size. Let me make the other one a little bit longer. Okay, that's pretty good. All right, so let's split that guy into 3 parts. The first guy, that'll be represent 2/3. It's pretty good. And then 5/6, I'm going to cut that in half first, and then it's going to give us something like 6 equal parts there. Okay, can you do me a favor, Jackson? Go ahead and shade in that 2/3 for me, please. Do you know how to do that? So we're going to take this. This is the 2/3 fraction. Yeah, exactly, right? This is going to be the 5/6 fraction. And then shade in that 5/6 fraction. So we got to shade 5 out of the 6 rectangles within that rectangle. Yeah, almost all of them except that last one. Which one's bigger? Which one's a bigger fraction?
5/6.
Yeah, 5/6 clearly.
Yeah.
That's pretty easy, right?
Yeah.
Does that make sense?
Yes, it does.
Yeah, like we're not even carrying out a mathematical operation here, really. We're just trying to think in concrete terms. I really, really strongly recommend that. I'm going to show you the operations to be able to basically you're going to express the fractions in with the common denominator, and then you'll be able to compare the numerators. But just kind of thinking about it logically, I think we can eliminate B pretty easily. What about answer choice C? How would you read that?
5/8 is greater than 6/10.
All right, is 5/8 greater than 6/10?
Okay, I'm not. Let's check.
Let's check. You want to do the triangle, the rectangle thing?
Yes.
All right, let's do that. 2 rectangles. Essentially equal area, roughly. And then we'll split that guy into 8 equal parts, the first one. So split in half, and then 4 parts within that. That's 8, and then this is going to be 10. Ooh. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. All right, so let's shade in 5 of the 8. Go ahead and do that for me, please.
Yes.
Okay. And then shade in 6 of the 10 for me. That's close too, isn't it?
Yeah, it really is.
And this is where we got to be careful, right? Because we don't know exactly, this is not perfectly drawn and measured out or anything like that. If you had a ruler handy or something like that, it might be easier to be a little more precise about it. But this is close, right? I don't want to eliminate it. Not yet. Okay? Not yet. So let's leave it. But let's look at answer choice D. Go ahead and read that for me.
4/5 is less than 2/9, or 2/9 is less than 4. Is greater than 4/5.
Yeah, 2/9 is greater than 4/5, or 4/5 is less than 2/9. Well, let's do this one with rectangle. I think this one's going to be a little more straightforward. By the way, just looking at those, do you know which one's bigger?
4/5.
4/5, yeah, it's probably going to be big. Just looking at it, you should be able to figure. But let's confirm it using the rectangle method. I'll take that, I'll split it into 5 parts. 1, 2, 3, 4, 5, and then 2/9. Ooh, it's going to be tricky, but we'll get it. 1, 2, 3, 4, 5, 6, 7, 8. Let's make it there. That'll work, okay. And then go ahead and shade in that 4/5. Yep, and then 2/9. Looking good. Okay, which one's bigger? Come on, this is easy, right?
4/5.
Yeah, 4/5 is clearly bigger than the 2/9, right? So we can eliminate answer choice D?
Mm-hmm.
Right? Okay. Now, let's stop. If this is as far as you get, okay, and you can't remember the exact operation when you take this test, I'm cool with that. You got a 50-50 shot on a problem that's not super easy if you're not super comfortable with fractions. And those are pretty good odds, right? We're talking like flipping a coin, right?
Right.
Good. I mean, it's better than like being like, man, I don't know how to deal with fractions, just picking something randomly. You got a 1 in 4 chance of getting it. But if you think about it logically, use some basic estimation, if all you do is eliminate half the incorrect answer choice on this test, you're going to know how to solve some of them. You're going to really succeed on the test. If on the trickier problems you don't know how to solve, you can eliminate half the incorrect answer choices. You're going to succeed on this. Does that make sense?
Yes.
Okay, good. Now, if you're going to guess whether it's A or C, which one would you go with? Which one's a true statement?
Wait, let me think. Probably.
I mean, it can be even just random.
I'm not sure.
Yeah, okay. That's it. Well, let's do some math here. Let's do some math. And here's how we're going to find out which one is the bigger fraction. We need to express each of these inequalities, each of the fractions here, we'll start with the answer choice A, with a common denominator. Okay? How do you find a common denominator again? Do you remember how to do that?
Yes.
Yeah. Okay, so what's the common denominator going to be for answer choice A?
For A,
Mm-hmm.
it's going to be like 21.
Well, let me teach you a little trick for common denominators. You may not find the lowest common denominator. The lowest common denominator is always kind of ideal. You may not find the lowest common denominator, but you will always find a common denominator if you just multiply the denominators. And what's 4 times 7?
28.
4 times 7 is 28. So let's make 28 the common denominator. It'll work. It'll work. It'll always work. May not be the lowest common denominator, but it'll be a common denominator, and that's good enough for us. Does that make sense?
Yes.
So let's make 28 the denominator. How would we express 3/4 with a 28 in the denominator?
Would it be 12 28s?
Well, let's do that trick. I'm not sure. I'm not sure. Yeah. Let's do that trick that I taught you earlier, right? Where we multiply it by some form of 1. And what are we going to multiply by 3/4 by in order to get a 28 in the denominator? Well, what do we have to multiply 4 by to get a 28 in the denominator?
You have to multiply 4 by 7.
4 by 7. So what's going to have to be in the numerator?
7.
7. Right? Because 7 divided by 7 is 1. We can't change the value of 3/4. Right?
Right.
We just want to change the form of 3/4. So now all we got to do is just multiply these fractions. So what's 7 over 7 times 3/4? Let's just multiply across the numerator. What's 7 times 3?
21.
21. And then 7 times 4, of course, is 28, which is why we chose to multiply by 7 over 7. Does that make sense why those two fractions are equal? 3/4 and 21 over 28. Does that make sense?
Yes.
Okay, good. All right, so that is less than, according to answer choice A, and we'll find out if it is or not, less than 5 over 7. And how do we express 5 over 7 with the 28 in the denominator?
So you would multiply it by 4 over 4?
Exactly. Great job, Jackson. You're catching on, buddy. Multiply by 4 over 4. And what does that give us?
20 over 28.
20 over 28. Ooh, those are close, aren't they close?
Yeah.
Ooh. No wonder it was so hard to estimate that. They're very, very close. By the way, which one's bigger?
3/4.
3/4 there is big, right? 20 over 28, obviously bigger. So that's not a true statement. That's not a true statement. Does that make sense?
Yeah.
Yeah, okay, so we can eliminate answer choice A. Gone. Adios. Okay. Let's look at, I'm going to clear a little space on the whiteboard here. Let's look at answer choice C. Again, we want to, look, answer choice C is looking good. Okay. But remember, we want to eliminate the incorrect answer choices and confirm the right answer choice just to know we're on the right track. And we can be really confident in our answer if we can do both. So how would we express 5/8 and 6/10 with a common denominator? Well, first, what's their common denominator going to be?
80.
80, yeah, right. Again, if you want to find a common denominator, it may not be the lowest common denominator, but a common denominator, just multiply the denominators. So how would we express 5 eighths with an 80 in the denominator?
It'd be
What?
50/80ths.
Yeah, what are we going to multiply by?
10 over 10.
10 over 10, exactly. So 10 over 10 is 1. We're not changing the value of 5/8, we're just changing the form. And what does that give us when we multiply that?
50/80ths.
50 over 80. It's probably how but yeah, you're right, 50/80ths. 50 over 80. And then how do we express 6 with an 80 in the denominator? We've got to multiply by what?
8 over 8.
8 over 8. Okay? Ugly looking 8 there. There we go. That'll work. And then, let's multiply across the numerator and denominator. What's 6 times 8?
48 over 80.
6 times 8 is 48 over 80. Also close. Huh?
Yeah,
Really close.
really close.
But which one's bigger?
5/8.
5/8 is bigger, so we can confirm it is indeed answer choice C. Any questions about that?
No, sir.
Okay, great. But again, and that is a specific operation, and that's not super easy if you're not super familiar with fractions. It's probably been a while since you've done operations with fractions. It's probably been since like middle school, where you've like really studied it closely. And but you don't even need, you can at least eliminate answer choice B and D using some basic estimation. You got a good chance at just getting it right because you're thinking strategically. Does that make sense, Jackson?
Yes.
Great. Okay.